Hello, some parts of the world. Welcome to my YT channel and welcome to my YT world. So, a while ago, I was just interrupted because there is a weak signal that I am stopping, okay, from the topic of momentum. Oh no, impulse, okay? So let's go up with this equations and formulas. Let's refresh and review, okay? The impulse, guys, okay, can be derived from the second law of Isaac Newton, which is force is equals to mass times acceleration. Okay, and then we treat the force is force net force, and then we will get the formula of acceleration. Acceleration is equals to the change in velocity and the change in time. So delta V over delta T. Okay, something like that. Okay, check. Like that. So since we have delta T, then we have to multiply both sides by delta T. So it will be cancelled out, and then we have force net times delta T is equals to mass times delta V. That's velocity, not volume, okay? So F net delta T is the impulse. Okay, so the formula of impulse is force times delta T. Okay, if there is a problem like that, given the time and given the force, then automatically you can solve for the impulse. But usually, this momentum and impulse can be related to each other and can be equated with each other due to the law of conservation of momentum. Okay, something like that. So we have now the final equation that goes like this. Okay, F net times delta T time is equals to mass times delta V. And mass times delta V, which is the velocity, right, is the momentum. And delta V is equal to the final change in the volume minus the initial change, not volume, final change of the velocity minus initial velocity, because I confused again with the V. Okay, like that, I must change this with small letter V or letter capital V. Never mind. Okay, something like that. Okay, so this is the equation we will be able to use if law conservation of momentum. Okay, like that. So the unit of impulse is Newton second, or it could be dyne second. And then for impulse, yeah, impulse is Newton second, sorry, dyne second, and momentum is kilogram meter second and gram per second. Okay, something like that, okay? So almost the same with the force. Okay, the only difference is in the denominator, second raised to the power 2. Okay, something like that. So we need to solve the problem. Now, before that, okay, I need to explain first the two types of collision. Really, guys, collision will really come out in the board examination. Really, in the general engineering. Okay, something like that. So it will collide like this, blah, 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 so and so. Okay, so that's really going out or come out in the board examination. Okay, so elastic collision and inelastic collision. Okay, inelastic collision. Okay, so what are the two types of collision? Elastic collision and inelastic collision. Okay, inelastic collision. Just listen, I don't have to write on the piece of the paper. If you want to write down in a sheet of paper, then you can write down. Okay, so inelastic collision, or what we call as perfectly inelastic collision. Okay, or nearly perfectly inelastic collision, because there's no such inelastic collision in the real world. That's only nearly inelastic collision, something like that. Okay, almost ba. Okay, and then the other one is elastic collision. There's no also total elastic collision. That's also near to the elastic collision. It's in between the elastic collision and the nearly inelastic collision in the real world, something like that. Okay, so and the elastic collision example, guys, examples are, the behavior of an ideal gas. That's an example of collision, because the molecules will collide with each other, right? So, and then escape to the atmosphere during evaporation process, right? Something like that, into the vapor state. Okay, ideal gas or something like that. Okay, and then also soccer. When you a soccer player will kick the soccer ball. That's also an example of, example of elastic collision. And another example also, playing billiard. There are different balls in billiard, and then when you like this, the first ball will push the other ball like that, okay? And then the other ball will stop and the other ball will move, okay? And that's an example of elastic collision. Okay, they're not moving the two going there, but the other will stop, something like that. Little bit stop. Meaning to say the mass of the first ball hit the other ball will be transferred to other ball. Something like that. Okay, that's elastic collision. Okay, so it's gonna be like that. Meaning to say, when they collide with each other, they are separated, or they will not go with each other. Okay? So for example, this is the calculator and this is my phone. Diba? When they collide with each other, like that. Okay? This calculator will go there and this cell phone will remain here. Something like that. So, the mass of this calculator will transfer to the mass of the cell phone will transfer to the calculator. You see, something like that. Okay? So that's gonna be the elastic collision. So in that manner, guys, in elastic collision, both kinetic energy and the total momentum are conserved. Charot. Okay? They are both conserved. Okay? Something like that. So we will use the equation M1 V1 is equals to M2 V2. Okay? Mass 1 times velocity 1 is equal to mass 2 times velocity 2. Parang ganon siya. Okay, now we go to the inelastic collision, or what we call as nearly perfect inelastic collision. Nearly, because there's no such perfect inelastic collision mangod siya. Okay? So ang example na niya is the celestial bodies in the outer space, something like that, and the orbits. Okay, the orbits, the planets. How many planets? 9, right? I forgot. And those planets will go to the orbit, something like that. So, collision will be happening, something like that. But before, long time ago, they said there's a collision there before the planet Earth exists, something like that. Okay? So, a long time ago, there is a collision. Okay, and that's why we have planets. Okay, so that's example of inelastic collision. And other also is when the two cars are hitting with each other, ganon siya. Okay, they will hit with each other like this. So when they hit with each other, they will go together moving, something like that. They will not separate. They will go together a little bit, moving there or there. So they have one mass already, the both. It's not transferred, but both of them have the same one mass. Okay? The two bodies. So that's example in elastic collision. So the mass of the calculator will be equal also to the mass of the cell phone, something like that. It's another story with the elastic collision, right? Something like that. And here, what is being conserved is only the total momentum. The kinetic energy is not conserved. Okay? It's not conserved really. And the kinetic energy is 0. Okay? So if it is not conserved, guys, so what will happen to the kinetic energy? It will produce the sound after the collision. Okay, sound. The sound energy or the acoustic energy, like that. Number 2, it will produce a heat energy, meaning during collision there's a heat produced. That's why you will see during the collision and crashing of two cars there's a smoke and there's a fire, because that is heat is released after the collision. And the other one also is the internal energy of those two cars bumping or collided with each other. Internal energy, that means it causes deformation. on the physical parts of those cars collided with each other. So the kinetic energy is not conserved, okay, and it is being transformed into heat energy, sound energy, and internal energy, something like that. So your formula will be used, class, is momentum 1 plus momentum 2 is equals to momentum total. Ganun siya. And then momentum 1, velocity 1 plus momentum 2, velocity 2 is equal to momentum 1 plus momentum 2 times velocity final, because as I told you earlier, their masses will be 1 manggod siya. So m1 plus m2 na siya times the velocity final. Ganun siya. Okay? So it's not the same with the other one, which is the elastic, which is m1 v1 is equals to m2 v2. Okay? So sometimes it will confuse in the problems, but we need to, sometimes you have to be alert. Okay? The data. We can understand also sometimes the data. If we feel, oh, the data is so many, then maybe this one. And if the data is not so many, then maybe the other one. Okay, or we can picture out what's happening upon the collision. Because it will be stated the problem most of the times. And then we can apply the exact formula for that. Okay, I have the problems here. Grabe, problem ba yun? Oo, ganun. Okay. This one. Or just read it 2 minutes to 5 minutes, okay? Okay, I'll write this one. Okay. But it looks like, guys, that the one who came out in the board examination is not like this. This is more difficult compared to the what is came out in the board examination. Simple, but this is more complicated, really. Okay. Like that. Because sometimes we have an attitude, if it is very easy, we don't attempt to solve that. That's a bad idea, okay? We need to solve also even though how easy, how easy to solve that problem. Do not escape, okay? There's a mentality of also like that. So, there's a chance that we may get wrong also because too much, what do you call this one? Taking for granted the easy questions, okay? Like that. So because you are focusing on the difficult problem solving, okay? So there's a disadvantage for that, huh? Do not focus too much on the difficult problem solving, okay? Because if that is the case, you complicate yourself, okay? Just go to the easy, average, above average, and a little difficult. Don't go to the most complex. Okay? If you want, then you can also, but just remember that the problem solving is not really that difficult as what you think, especially in examinations. Okay? Like this. And in fact, in class is more difficult. The problem solving in the class is very difficult than the board examination. Really. The examples of the teachers and the instructors, okay, are more difficult compared to the board examination. Okay? The only thing is we are only pressured. Okay, time limit like this, and then we're really pressured to pass like this, and we have something in our mind that if we fail, what will others think of us? Ganon siya. Okay, so forget those, thoughts like that, bad thoughts. Okay? Klaro na siya, ha? Okay, ako na bumasa. Okay, a 1,300 kilogram car is moving at 20 meter per second. And a 900 kilogram car moving at 15 meter per second in precisely opposite direction participates in the head-on crash. Okay, head-on crash is collision. If we consider this to be a perfectly inelastic collision, see, what is the velocity of the cars after the impact? So here, we are very lucky, guys, because it was mentioned perfectly inelastic collision that we will use the m1 v1 plus m2 v2 is equals to m1 plus m2, ganun siya, times the velocity final. Okay? Or it is derived from p1 plus p2 is equals to total momentum. P is the momentum. Okay, I forgot to tell you. P is momentum. Okay? So sometimes F is force, but the impulse is just I think so. Just denote that with capital I, ha? Okay? So we will solve now. So, given. Saan ba itong given? Uy, charot. We should illustrate first, ha? So that we can understand that. Illustrate first, so that we can understand what is the required in the problem. Ganon. Okay? Uy, talaga, ang dami ko ng mga papel. Okay, so, uy, wala ko, gamay ra ka kong table. So, di ko makaklaro og suwat. Charot! Okay, I don't have a very big table and it's very difficult for me to, write like this. Okay, so number 1. So, mass 1 is 1,300 kilogram. Okay. And moving at 20 meter per second is velocity 1, right? So 20 meter per second and on 9 kilogram the M2. Okay, 900. Okay. And the speed is 15 meter per second. Okay. Like that. But take note guys, in precisely opposite direction. See, this is negative. The second car, ha? Opposite direction man siya. So, mabita kaya nagbangga sila. Okay, so opposite direction sila talaga. Or else, they will never collide. Common sense. Okay? Like this, I will show you the car that being collided with each other. Ganon. So this one. Okay? Okay, they're collided with each other. Okay? Opposite siya yung isa, ha? So, if this is considered as a perfectly inelastic collision, what is the velocity of the cars after impact? Meaning to say, the final velocity. Okay? Of the two cars. Because these velocities mentioned here are velocity of each car man before they are colliding with each other man siya. Okay, so use the formula momentum 1 plus momentum 2 is equals to momentum total. Okay, like that. Okay, always like this, ha? And then momentum 1 mass 1 velocity 1 mass 2 velocity 2 is equals to, okay, mass 1 plus mass 2 times velocity final. Ganon. This one. Use this one. Okay? Use this formula. Memorize. Okay? Perfectly, nearly perfectly in elastic collision. Inelastic. Okay? Like that. So, substitute values. M1, 1,300. Okay? Kilogram. Okay? V1 is, what's this? 20 meter per second. Okay? Plus M2, 900 kilogram. Okay? Times 15 meter per second. Okay? Like this. Is equals to 1,300 kilogram plus 900 kilogram V final. Okay? Okay, ganun siya. Ganon. So, solve na siya. Try to solve this one. Okay? So, 1,300. Be careful also in pressing the calculator because it can cause error. 1 times 20 is equals to 26,000. Okay. And then 900 times 15. Okay. 13,500. Okay. And then 1,3 plus 900 kilogram, right? Yes. 1,3 plus 900 is equals to 2,200. Okay, like this. And then velocity final. Okay, so reverse this one is equals to 2,200. Velocity final is equals to ganun siya, 26. But this one is negative, the 900. So let's just put it negative first so that it will not be confused. Okay, negative, ganon siya. Okay, so negative siya, so 13,500 minus 26,000, ganon siya. So it is 12,500 since 26,000 is bigger than 13,500, so it will carry the sign of positive. So positive 12, okay, 12,500. So divided by 2200 is 2. Okay, like that. So VF is equals to 5.68 meter per second. Okay. So if you are not contented with your answer, then review. Okay. So the velocity final, it looks like realistic. Okay. It looks like realistic, guys, because it is already stopping, and then the final velocity is expected to be lesser, right, from their initial velocities. We have both initial velocities, right? Okay, so it is expected that the final velocities of the two, okay, will less or reduce. It will never increase. So that's our first point. So it's gonna be correct. But review again because maybe problem because it's a negative sign. Okay? So like this. So negative man siya kay ang 900 opposite siya. Okay? So like this. So 1,300 times 20. So review lang good siya. Okay, then 900 times 15 is equals to ganon. Okay? Okay, ganon. I'll review. Okay, because you don't know, right? Okay, 22,000. Okay, 1,300 plus 900 is equals to 2,000. Okay, so 26,000 plus 13,500 divided by 2 like this. Okay, so this is correct. We carry the sign first. Because I proved if not carrying the sign first and then after na lang siya, so the answer is very big man siya, 18.9. Okay, so we can, there are also sometimes that you can carry only the sign after. Okay, you will just put negative in the end. Okay, but it's better to put negative in the solution because of its opposite siya, negative siya, padulong mo siya sa pikas, right? Okay, so padulong siya like this, the negative, padulong dito positive. Oh, if the car is going to the, you know, like this, okay, going here to the left, negative, right? Going to the right, positive. And this 900 kilogram car at a speed of 15 meters per second is going there to the left, so negative siya. Okay? So the answer will be 5.6 meters per second. Now, if you try to solve the other formula, let's use the other formula. Let's say it will be equal, if you use the law of conservation of momentum. Let's example lang siya. Okay? So let's take that as an example. Okay. M1, P1, okay, plus P2, okay, initial, okay, is equal to P1, P2, final. Okay, like that, And then P1 is equals to 1,300 times 20 plus 900 times 16. Okay? Like that. And this one, M1, which is 900, no, 13. Okay? And then again, 20 plus M2, ano siya? M2 is 900, right? 900. Okay, 900 times the velocity 2. Wala pa man kay velocity 2. Okay? Like that. Okay, let's prove lang kung the same answer ba siya if using the other formula, okay? So, 900 135, then like this, 13,500. And then 20 times 1300 is equals to 26,000. Okay. And the other one also is, oh my gosh, 13,000 times 20. Oh my gosh, it will be cancelled, right? I don't know. Let's just do this one by one. Okay. Then 900 V2. Okay. So, add mo siya. Okay, daan. So, 26,000 plus 13,500. So, 39,500. Ganun-ganun siya. Okay, then we have 60,000. Okay, plus 900 V2. Okay, now, the P2 is negative. Okay, negative siya. Okay, kung negative siya, so negative here. Okay, here, negative here, and negative here. Okay. So, 900 times 15 is equals to 13.5, so minus siya. Negative na siya. Okay, then negative din siya. Dari-ari. Yan. So, after i-minus mo siya, this is minus 13,500 is equals to 12,500 din siya. So, 12,500 positive because it's bigger man siya. Okay? And then, negative din siya. Okay. So, V2 is equals to, ganun. Okay. 12,500. Okay, minus siya. Minus 260,000 is equals to 24,700. Carrying the sign. That is negative. Okay, because this is positive. Ganun siya. Minus this one. Okay, this is negative. So, negative ng punti siya. So, negative 900 V2 is equals to negative 247,500. Ganun. So, divided by 900 equals to, okay, so 247,500 divided by 900. Right? Ganun. So, di siya possible because the V2 is very big, 275 meter per second. Possible siya. So, we cannot use this formula, ha? Okay? So, in perfect collision, good siya. Okay, not the other one, the perfect collision. Because it's mentioned also in the problem, right? Okay? So, if you use the other formula, which is P1 plus P2 initial is equals to P1 plus P2 final, it will never give the same answer. Okay, it always use the inelastic collision, which is the P1 plus P2 is equals to P2. So P is momentum, okay? Then M1 V1 plus M2 V2, okay, equal to M1 plus M2 close and open parenthesis times the final velocity. Okay, ganun siya. Okay. Now, question number 2. Charot. Okay, a 50 kilogram object is moving at 18.2 meter per second when a 200 Newton force is applied opposite direction of the object's motion, causing it to slow down. So, opposite din siya, meaning to say negative. Okay? And then, slow down to 12.6 meter per second. This is the velocity. Okay? This is the final velocity and this is the initial velocity. Something like that. Okay? How long was this force applied? So, it's asked for the time. So, which formula that involves the delta change in time or the time is the impulse. Okay, now we will use the formula of impulse. Force times delta t is equals to mass times delta velocity. Ganun siya, then substitute. Okay? Okay, so let's do it. Okay? So, this is now the conservation of momentum. Okay? Like this. So, this is now elastic collision. Yes. Okay? So, we have number 2. So, a 50 kilogram object, so mass 1. Okay. And then, moving at 18 meter per second. Okay, that is velocity 1. 18.2 meter per second. Let's say this is the object. The object is not mentioned. What's this object all about? Ganon. It's moving here. Okay? And then 200 Newton force is applied in opposite direction. So whereas there's another object here. Okay? Let's imagine. Okay? An opposite direction here. Okay? So this is negative in this side. So this is 200 Newton ang force triari. Okay? 200 Newton. Okay. And then, to slow down to 12.6 meters, so nakakay V. Nakay V2. Okay? Nakay V 12.6 meter per second. Because it's 2 meanings the second object na siya. So, 1 and 2, gano'n, chuba-chucho. Okay? Muna siya. Muna siyang illustration. Okay? Okay. Now, okay, so use the formula F times delta T, change in time, is equals to the mass, okay, mass times the delta V, okay, so like that. So, F, negative 200, substitute na ta, negative 200 Newton, okay, delta T, wala pa, okay, then the mass, of course, we have the mass of 50 kilogram na ato siyang likuan. Okay, ganon. And then, velocity final will be equal to Vf minus V2. Ganon siya. Okay, so Vf, we have 12.6. Okay, 12.6 meter per second minus 18.2. Okay? Delta velocity is a change naman siya na velocity. So, ganon. Okay. So, in this case, guys, the second block was moved. And then, the mass of the second block was receiving the mass of the first object. So, that's why we only use this 50 kilogram. Okay? We don't need the other mass. Okay, because it was transferred man siya. Mura giduot ra siya ba? Okay? Sa second, okay, nga object. This calculator and this is the pencil pen. So the other one is moving direction like this. Okay, so this calculator will move. This is the object and then this one is steady. Meaning to say the mass of this pencil pen is transferred to the calculator. That's why we use only the mass of 50 kilogram. No need to find the other mass of the other object. Okay? So, it's gonna be like that. Okay? So, don't complicate because it's only mass given and then in this situation, the mass is transferred only in the theory. Okay? Like that. So, we have now i-minus mo siya, calculator. Okay? So, 12.6 minus 18.2 is equals to times 50. We have 280. Okay, negative 280 siya. Kaya dako man 18.2. Okay, and then negative 200. Delta T, what is the answer for this? Divided by 200 equals to 1.4. So 1.4 second, positive na rin siya. So 1.4 second, the time. Okay, it takes, oh my gosh, it takes 1.4 seconds only the force applied to undergo this kind of collision to slow down to 12.6 meters the other object, something like that. 1.4 seconds is very fast. Okay? Because this is a collision problem, it's expected to be fast. Right? Collision is very fast, it happens very quick. Okay? And just enough, 1.4 seconds, very quick, so it really hit the other object. Ganun siya. Okay? So actually there are a lot of problems like this, but it's just like, you know, you should think properly and analyze properly what's going on. But it's in here that you will carry the sign, if going to the left, the negative. Okay? And then substitute really the negative sign there in the equation. Okay? So, klaro kaayo because they are opposing with each other ba ya? Okay? Do not use the positive, Maybe because of the equation plus, and then you will never carry anymore the negative. Okay? So this is vector quantity. Okay? As I told you, both impulse and momentum is a vector quantity. Okay, we need to consider the direction. So meaning to say, we consider the negative sign. Okay? Like that. So speed doesn't require the sign. Okay, but velocity requires the sign. Okay? And meaning negative is slows down. Positive is accelerating. Negative is decelerating. Okay, something like that. Okay? Unless fraction is also stated there. Okay, then you have to add something like that. Then ganun siya, chuba chuchu. Okay? So thank you so much for listening this. It looks like easy, right? Charot! Okay, so finished. I hope you like this video. Then you can subscribe my YT channel, and then you can share to anybody else. The if you found it very informative to you, the academic information you can share also to your daughters, to your sons, or then you can also write in a sheet of paper and then study this if you have examinations related to this impulse and momentum. Okay, because this will always come out in the board examination, sure. Okay, but only two items, like not so many, but at least it will come out. Okay, like this. Kalas. Thank you so much, everybody. God bless. See you later for another live streaming and vlogging. Thank you so much.